My name is Michael Head. I'm General Counsel and Director of Contracts at Pyramid Technology Solutions. We are an IT consulting, software development, and IT staffing company based out of Indianapolis, Indiana. Came out here to see you guys. Like to stay. We also have offices out here. At any given time, we have 200 to 300 consultants placed in public and private sector clients. But you're not here to hear me talk about contracts today. What we're going to talk about is integrating data analytics. And I'm the wrong guy to talk to, but lucky for you, I've got two heavy hitters, some friends and collaborators of ours who are going to talk to you a little bit about that. This is Theja Birur and Asif Qamar who've come here to talk to you guys a little bit about that. I know we're short on time, so I'm going to let them jump right in. Theja?
Hello everyone, my name is Theja Birur. I'm a healthcare IT consultant, public health, CDC. I've been using and building data marts for the past 14 years. I'm not here to talk about this one, but it's my chief data scientist. He's a Silicon Valley scientist, Asif Qamar, so I'll pass that to him.
Thank you, Theja. Good morning, folks, and I hope we have a lot of fun in the next hour. I'd like it to be an interactive session, so please ask questions. I'll start with my name. It's very hard to pronounce, so as if this will be a fun session. So a little bit about my background. I have multiple backgrounds. I have background in computer engineering, in computer science, in computer large-scale architecture, in Oracle, in databases. I have been involved with big data and machine learning. Machine learning happens to be what we call AI today, happens to be a core passion when applied to massive amounts of data. And in one form or the other, I have been doing this for the last 25 years. It's been, I really mean it, it's been an absolutely marvelous journey. This journey started in different forms, data that has to do with particle accelerators, data that has to do with NASA data on astronomy, analyzing that data that I encountered in a corporate world, in Siebel, in Oracle, and in human resources management. And the beautiful thing about data is that every data has some stories to tell. It's amazing. We think of data as locked up in databases and silos, as boring tables and SQL queries. But my perspective on data is completely different. My perspective is data is poetry. You just have to express it in the right way. And I hope I'll be able to convey some of that to you folks. When you bring data up, amazing things happen. So that's the journey we'll take in the next 1 hour. This is a quote I like to say. It's a defining quote for me. It says that all truths are easy to understand once they are discovered. The point is to discover them. But how do you discover truths? We are in the scientific world. We discover truths by gathering data, by asking questions, gathering data, and then looking at the data, analyzing the data, and learning from the data. It's the ask, measure, learn cycle that is science. But data, how much data do we have? We used to live in a world, throughout human history, we lived in a very interesting world. Data was hard to gather. Census data, it would take a massive army of human beings to gather that data. On most things, we did not have data. So then we did not have the computational resources to deal with that data. Computers throughout history has been very, very expensive. Right? Today, we are in a very interesting time. This is the only time in history, and I'm sure you all will appreciate that this is really the first time in history when we have something quite surprising. We have an inversion of sorts. It's an inflection point. We are at a point at which hardware has become extraordinarily inexpensive and extraordinarily fast. Today, the Intel chips and so forth, they run at gigahertz. And they are massively multi-core beasts out there. Right? You get an NVIDIA card. Those are massive graphic processing engines that you use for deep learning and so forth, for machine learning systems. Memory has become fairly inexpensive. We all go upgrade our computers. We all know that. It's become very inexpensive. Networking, how many of you remember 20 years ago we used to do dial-ups over phone lines? Isn't it? Right? And the state of the art used to be 64 kilowatt and so forth. Today, just in my neighborhood, the gigabit fiber came. Right? So we are in a different world of plenitude as far as resources are concerned. In fact, in a world of practically embarrassing plenitude. Today, if you want to go and reserve for yourself, let's take an example, and this was a real case study, 1,000 nodes to do a giant computation because a question is bothering you, data is available, and you would like to answer that question. How would you answer that question? You go to any of the cloud providers, let's take Amazon, you would reserve a lot of instances, you would fire up your mathematics, you would grind through it, your entire computation would run for, let's say, an hour. Right? And you have your answer. Then you write a check for, let's say, $100 or so to Amazon. You could not imagine doing it 10, 15 years ago. 1,000 machines would be, what, millions of dollars worth of budget? Right? Which approval through management would take, through government would take, what, a couple of years? Right? It wasn't possible. So today we are in very interesting times. You have a question. You're curious about something. Very, very easily, you can compute through the data. You can analyze through the data. So this is the golden age of analytics. This is the golden age of machine learning and AI, which is absolutely unprecedented today. And not only has the hardware been getting better, one of the things that has been happening is these quiet academics, these mathematicians, these AI experts, they have been having a revolution of their own. Wonderful algorithms have been coming out over the years. It's an amazing, amazing revolution. Compared to the algorithms we had access to 30 years ago, we have many new things. We all hear about deep learning, deep neural networks, support vector machines, boosting, and so on and so forth. We hear these words in one form or the other over the media. Perhaps we don't understand what these words mean, but they seem to be all around us, self-driving cars and whatnot, and they all somehow seem to have something to do with these algorithms. At the same time, we hear that we can now do computations at a scale we never thought possible. We are doing computations now at what? People speak, Google speaks of planet-scale data centers. They're clusters which have 10,000 nodes, which treats the entire data lake as one giant, essentially think of it as one giant file that it is computing through. And a single computation runs through the entirety of it. Just imagine the scale of it. And the technological advances like this MapReduce, distributed file system, Bigtable, HBase, Cassandra, Spark, all of these words, they sort of surround us in the technical media around us. And these are truly remarkable revolutions that we have seen in our times. In fact, these are the defining things of our 21st century. And they really are differentiators in significant ways from the previous century. So this is the opportunity. What can we do with this opportunity? If this opportunity has been there, well, we should be changing the world very, very fast, and it is changing. But what are the challenges that we encounter when we try to do this? And the first challenge that we encounter is obviously data itself. While technology is improving, while our intellectual understanding of how to deal with the technology is increasing, we have more scalable systems, we have far cleverer mathematical algorithms. Data, it turns out, is growing at a pace that still outpaces our technical innovations. It's quite remarkable. Every time the internet comes about, what does the internet lead to? It brings the world together in a truly global village. Everybody is talking to everybody. There's tremendous, we are a gregarious species, so we all start talking. Tremendous amounts of data comes out. I wanted to point out what this means. There are 3.6 billion internet users. Well, that's disappointing because that's perhaps half of human population. In due time, it will hopefully have much better coverage, but that's still a lot. We have, right? It turns out that we are a gregarious species. We like to express ourselves. So these 3.6 billion human beings who are on the internet have managed to create 1.2 billion websites. Hopefully each website with multiple pages, multiple stories. Every day this thing is increasing. We send more than 500,000 emails a day. 500 million, I mean. Then these are the number of searches that you see every day. The posts, the Twitter feeds, the videos, the pictures that we upload, we feel that everything we do is of some interest to our loved ones, to our friends, to our colleagues. And there is a technological platform that facilitates sharing of all this information. So what it has effectively done is, it has made huge amounts of information available, data available. It comes as a torrent at us. The thing is, can we deal with it? Do we have the means to deal with it, to analyze it? Data, unless you do something with data, it's dormant, it's dead. You have to lift it up, you have to visualize it, you have to analyze it, you have to listen to the narratives that it has to tell, that is embedded, latent in the data. Right? So how do we do that? That's sort of the journey. That's what I have been doing, obviously, for 25 years in all the various scientific and engineering enterprises that I have been busy with. But I'd like to, I was asked in this presentation to talk about, in general, what are the core things that you learn over the years. How would you go about thinking data architectures? So it's a very finite time. I'll give you a few high-level pillars or steps that one has to have to create data architectures. Right? After this, I'll be open to questions. Please feel free to ask questions. During our session, please speak up. Right? It will be far more fun if all of you ask questions and interact. Right? You all know about all of this. We are together. So I say that in our world, the challenge is that we have two towers of Babel. Well, as you know, the story of the Tower of Babel, was that people couldn't, they had different languages, and so they couldn't talk to each other anymore. We have a similar thing. We have data fragmentation. We have data and ginormous amounts of data. But where is this data? In this guy's SQL server. Even when it is in SQL databases, they don't exactly talk to each other. Schemas are different. Right? Have we all encountered that? Even if we have the same Oracle technology for databases, this department schema and this department schema about exactly the same logical entity are entirely different, so that we have to do all sorts of extraction, transformation, and loading to reconcile the data. Right? Data fragmentation is a primary thing. Now there's a variety of data. Data increasingly is coming as JSON, as XML, as feeds, Twitter feeds, as just messages. There's sensors. Today, in the world of IoT, data tends to come as these little bits, the torrents of these little bits. These are the sensor readings. And we have to deal with this huge variety of data. When you look at the whole variety of data and the need of the data to change its formats all the time, one of the realizations people had towards the turn of the century was that perhaps when we were rigid about structure in relational systems, very well-defined schemas, the age has gone. It is very useful where we truly need structure, but it turns out that a giant number of use cases, we do not need such a rigid structure, we do not need such a rigid schema. And that led to sort of more relaxed schemas or no schemas at all. It was typically called the NoSQL movement, or sort of not only SQL movement, depends upon how you interpret NO. Right? So in which there was tremendous innovation, big table of Google that got open sourced and became, in some format, the H-based Apache project, Cassandra, and these are things that we all have heard of. What they do is they relax the notion that you need very strong structure. When you relax the notion of strong structure, what you end up are creating this, unlike data warehouses, which is very structured data, very disciplined data, you end up creating these data lakes. Right? And you say the primary concern is to ingest data into the data lake. Let's have a unified data lake into which we can bring things. But we'll talk about it in a moment. We have another problem in our space. What is happening is there are two kinds of people that I encounter in technology. One are people who are extremely excited about the math, the algorithmics, the technical aspects. They would be all the time excited about the new data structure that just came out, the new algorithmic improvements that just happened. And you hear that they have journals and they have things. So they have one set of people making deep contributions. And then there is the other set of people who are the domain experts. They say, no, wait a minute, all these toys are good, but in real life, they are meaningful only if they solve real human problems. They have to mean something. These are engineering things. A bridge has a purpose. What purpose does your algorithm have? We will do something with it. We'll build applications. These are people who understand domains. They understand what human resources. They understand transportation. They understand all sorts of domains. And these are the deep domain experts. In this deep domain expertise, what you find is you have a lot of tribal knowledge. You have some knowledge that can be quantified in textbooks. But there is also this distillate of experience, this thing that is essentially an oral tradition, this thing that is passed from a person, a mentor, to his junior team, which really cannot be captured like that. It is part of the tradition, the tribal knowledge. Now, these are two completely different worlds. Whenever you want to make something remarkable, you have to find a way to bring these worlds together. Right? This is my experience in just about all the big projects that I've encountered. The question arises, technologically people will say, we want to solve it this way because that looks the most exciting. And then it meets reality, and reality says, no, we need to do things very differently because we have to address this complicated problem, and that also needs to be addressed. And some of the best innovations in technology actually comes pondering over the complications that real life, real situations bring about. Right? And it leads to, obviously, that's how we are having a lot of our progress. So I'll talk about this. These are the two worlds. Today, if you look at government departments and also different companies and so forth, you find that this is the world, deep expertise. And there is the Silicon Valley culture, right? That sort of, the stereotype is you live in the basement and you keep dreaming algorithms, right? So, right? So these are two worlds. How do you bring them together? Next, obviously, so let's go through all of this step by step. We have the data diversity. We talked about it. But the interesting thing about data diversity that it has done is, or the challenge and the opportunity, every challenge is an opportunity if we can find a way to deal with it. It is the following. So far, this big iceberg of data that is continuously growing, there's only a little bit of it visible. There's only a little bit of it that we are actually able to use. The deep tragedy is we have this hidden part of the iceberg of data continuously growing that we have not so much as begun to address, begun to mine. Countless discoveries, countless interesting insights and findings are hiding in this data. Really, it is far easier to gather data than to actually analyze it. Right? Analysis is where the fun begins, where you make this dead data alive. You do something with this data. Gathering is just passive. You have the architecture, the hardware, the stuff, and you gather the data. Right? It is challenging, but it is a challenge we have learned to overcome. It's the easier part of it. What do you do with it then? We'll deal with that.